Hello everyone, this video is about glass electrode. So in previous video we had discussed about the types of electrode and we had seen the secondary reference electrode, which is the calomel electrode, in detail. Now glass electrode is another type of electrode which is actually a ion selective electrode. So there are some electrodes which come under the category of ion selective electrode. Glass electrode is one of those. As the name suggests, ion selective electrodes are the electrodes whose potential varies depending upon the concentration of only a specific ion present in the solution, and it does not depend upon the concentration of the other ions. Like, let's consider and first understand how the glass electrode is constructed, and then we will see that with the concentration of which ions does its potential vary. So as you can see, the construction of glass electrode is very simple. It is having a glass tube. So this is a thin walled glass tube which is having very high electrical conductivity. So this is a broad glass tube. In glass tube, there is a silver wire. So this is the silver wire which can be used for external connection with other electrode, because for formation of a cell we need two electrodes. So this is the silver wire. Below you can see there is a plate. So this is a silver plate coated with silver chloride. So this is a Ag wire, silver wire, and here is a plate of silver wire coated with silver chloride. Now this this plate is dipped in a solution of 0.1 molar hydrochloric acid. So concentration of this acid depends, is this concentration of this acid which is used in the glass electrode remains constant. So this is a simple construction of glass electrode. It is having a broad glass tube, highly sensitive glass tube which is having high electrical conductivity as well as pH sensitivity. Inside it, there is a wire of silver, a plate of silver coated with silver chloride, which is dipped in a solution of 0.1 molar HCl. So why 0.1 molar HCl is used, and also this glass tube is sensitive to pH. That means this electrode is used for measuring the pH of a solution, pH of an analyte. So the potential of this electrode varies depending upon the concentration of H plus ions which are present in the analyte. So when this electrode is actually dipped in a solution, or we can say analyte of which is having H plus ions, the potential is developed across the membrane because of the difference in concentration of the H plus ion which is present in the external solution, and as well as H plus ions which are present in the internal solution. So here the internal solution is 0.1 molar HCl. So it is having H plus ions and Cl minus ions. So when this electrode would be dipped in an analyte, the potential would be developed across the membrane depending upon the concentration of H plus ions in the external solution. So glass electrode is an ion selective electrode and its potential varies depending upon the concentration of H plus ions present in the external solution. That is why we maintain the concentration of the internal solution constant, which is 0.1 molar. Also, there is another type of glass electrode which is called as a combined electrode. So we know for formation of a cell, as I said, we need two electrodes. So this is a combined glass electrode. Why it is called as a combined glass electrode? Because it is having both the indicator electrode as well as the reference electrode inside it. As you can see, again, the construction is same. It is having a highly sensitive glass tube which is pH sensitive, which is having high electrical conductivity, but it is having a internal reference electrode also, silver chloride reference electrode, which is the internal reference electrode because it is present inside the glass electrode. Plus it is having the ion selective electrode which we saw here. So it is same, it is having an ion selective electrode whose concentration, whose potential is going to vary depending upon the concentration of H plus ions in the external solution. It is also having a 0.1 molar HCl solution which is present inside. So the potential is going to vary depending upon the concentration of H plus ions in the external solution. In glass electrode, it will have two wires which can be connected to the meter. So which meter we can connect it to measure the pH, we're going to see ahead in the video. Also here in reference electrode, the solution used is KCl solution. So this is AgAg cell reference electrode of the sample, and this is AgAg cell reference electrode of the internal, which is dipped in 0.1 molar HCl. Now this is the Nernst equation for glass electrode. So E glass would be equal to E standard, the potential of the electrode measured under standard conditions of temperature and pressure, minus here it is actually RT by NF. So if you put the values of RT by F, R is the gas constant, T is the temperature, F is the Faraday's constant, and you multiply it by 2.303. So here it is ln. When we convert ln into log, we have to multiply it by 2.303. So you will get this value, which is 0.0591 log to the base 10 of H plus ions. So the potential of glass electrode is going to vary depending upon the concentration of H plus ions in the external solution. So this is also very clear while writing the Nernst equation. So how can we represent the glass electrode? So glass electrode can be represented by Ag, that is the silver wire. It is coated with AgCl because it is having a plate of silver below which is coated with silver chloride. So AgCl electrode. It is in direct contact with 0.1 molar HCl solution, and which will be in direct contact with H plus ions which are present in the test solution. So this is the glass membrane which is going to separate the internal solution with the external solution. Also the Nernst equation, we can write it in this way. Now this is E glass is equal to E standard minus 0.0591 log to the base 10 of H plus ion. So we know pH. pH depends upon the concentration of H plus ions, and the relation between pH and H plus is that pH is equal to minus log to the base 10 of H plus ion. So we are going to remove this log to the base 10 of H plus ion, and also the minus sign we can replace it with plus because we are simply writing pH in place of it, because pH is equal to minus log to the base 10 of H plus ions. So these are the ways in which the Nernst equation can be written for the glass electrode. Now here there is the construction, how the glass electrode is constructed as we saw according to the diagram. So this is how it is constructed. Now, as I said, glass electrode is going to develop a potential which will depend upon the concentration of the H plus ions in the external solution. So if it is a simple glass electrode, ion selective electrode, we need to form a cell, means we need to connect it to the reference electrode for finding the potential. If it is a combined glass electrode, then we don't need to connect it with another reference electrode like the calomel electrode. So let's see how we can do it with a combined glass electrode. Now here it is shown. Now this is a glass electrode which is actually a combined electrode because it is having both the reference and the indicator electrode in it, as we saw in the previous slide. This glass electrode, as you can see here, it is made up of a glass tube, broad glass tube, and at the bottom there is a bulb which is highly sensitive, high conductivity and pH sensitivity is there. Also, there is a solution inside this glass electrode of 0.1 molar hydrochloric acid. So, the concentration of hydrochloric acid inside the glass electrode is maintained constant. This glass electrode is connected to an equipped pH meter. So, this is a pH meter which you can see, which displays the value of the pH. So, this value which you can see, it is a value of the pH of this solution, which we can also call as analyte. So there are three knobs on this pH meter. One is the mode, another is the standardization knob, and then third one is the temperature knob. So there are three knobs on the pH meter. Once we connect it, the pH meter is going to show the value of the pH of the solution. So this glass electrode is used for measuring the pH of the solution in pH metric titration. So this is going to, so this pH meter is actually going to show the values of the pH when we are going to perform the titration. So in titration, we are going to add some titrant from the burette into this analyte, and then we are going to note down the value changes. So this is the use of the glass electrode. It is used to measure the concentration of analyte in which H plus ions are present. Its potential is going to vary only depending upon the concentration of H plus ion, and it is not going to vary according to the any other ion. Therefore, it comes under type of ion selective electrode. In next videos, we are going to see some more example of ion selective electrodes for your better understanding. So that's all for today's video. If you like my videos, please do like, share and subscribe. Thank you.